Gilt is an interface builder for X11 and Lisp and works like other interface builders. It has a palette of objects you can create, and you select which ones you want and put them in the window. Unlike some other interface builders, you can directly edit the string labels in place. You don't have to go to a dialog box, although there are property sheets for setting other properties like the colors and the fonts. You can also remove items and add new ones interactively. There are two different palettes available for the Gilt Interface Builder. One contains the motif look and feel widgets, and these widgets were actually created with the Garnet toolkit without using the C implementation of motif. The other set of widgets have an innovative look and feel, which we call the Garnet look and feel. Of course, you can move objects around, you can change their size, and the internal relationships in the objects are maintained with the constraint system built into Garnet. Now what we're going to do is bring up the align command, which will, and we'll put them all in a row. An interesting thing about this part of the interface builder is that it was created in about a summer by a student as a project, and this is possible to implement it this quickly because of the built-in support for interactions in the Garnet toolkit, the low-level toolkit. One thing we've noticed is that often in dialog boxes you have dependencies among the widgets. For example, the ones that are gray here depend on the selection in the menu, and often the values in a widget. For example, this whole dialog box computes a single value, which is a font. And these dependencies and interdependencies amongst the widgets often require callbacks in other toolkits. In fact, this dialog box requires 13 callbacks in conventional toolkits. In Gilt, we have built-in mechanisms to allow you to define the dependencies and the interdependencies among the widgets. And this is controlled by a special window called the value control window. The normal value for a widget is just the string label, and you can see at the bottom of the window that the value is the current string. What we want to do, however, is make the value of the standard font button be computed based on the values of this other widgets. However, using the function that gets the standard font. Now, however, this function takes special constants, not string values. So we have to transform the return values from all the other widgets, the other three widgets. The Courier Helvetica choice, times choice, it automatically determines, and the size choice here is the same way, it automatically determines a transformation. But for the middle widget, which is checkboxes, bold and italic, it can't determine the transformation to use, and so it requires the user to give the values for each of the branches. So you go into run mode, you click on the widget to put it in each of the states, and then in the bottom of this window you just type in the value to be returned in that particular state. And it automatically constructs the case statement, which goes in the filter function here. And after we finish typing in all these values, then it will have the appropriate constants and can execute the get standard font routine correctly. In order to figure out the transformations for the other branches, it's using the type information available in Lisp about what parameters this function takes and what types they are. Now we've finished with that branch of the widget, and now we're going to do the other font branch, and this is going to work in a similar way. We're going to call a function that will return a font given a string label. Now, of course, this can sometimes fail if the string is an illegal value. So what we're going to do is add some error checking using this special error check button. And rather than requiring a callback procedure, all you have to do is to specify the string that you want typed out, and it will automatically construct the error handling function for you. So we'll type in the string we want, and you can also use the values of the widgets to make the string more informative just by clicking on the button, and we'll put that into the string here. And then, of course, we'll be able to execute this immediately the fact that we're running in Lisp makes this kind of interactive exploration of the interface much easier, and it's much easier to just execute these functions as soon as we click OK. So now we'll try this out. We'll go into Run mode and type in an illegal font name, and it will pop up a dialog box. Okay, the next thing we're going to do is handle changing the different widgets gray, where they become illegal. And you do this in a similar way. You just select the widget to become illegal, and then you select the widget that controls whether it's legal or not. And we can do that for the font name widget here, and then you can try that out immediately, of course. And then we'll do the same thing for the other three widget sets at the top, the buttons, and then we get this behavior where when you click on one branch, the other branches' widgets go gray. A similar set of dialog boxes let you control the font of the example string at the bottom so that it will compute its font based on the values of the other widgets, and the return value of the dialog box can be computed in the same way. Thus, we have eliminated a large number of callback procedures, and the procedures that are left, the ones that convert a string to a font and that convert these constants to a standard font, are taking normal parameters, constants or strings, that they would expect from any library, rather than taking widget values. Another innovation we've added to the Gilt Interface Builder is the handling of styles and tabs. We've noticed that in many toolkits, widgets have a large number of parameters. For example, the menu in Motif can have up to 50 different parameters: the fonts, the colors, the styles of the little diamonds, and the underlining, and all sorts of things. We can include all of this information in a single graphical style, and this allows you to have multiple dialog boxes have consistent looks even across multiple applications. Tabs lets you align things in a consistent way across dialog boxes also. So for example, we can have a particular style shown here that will have the radio buttons with the little boxes on the right and the labels in italic. We can give that a name. We can give that an alignment here on the tab. It's left aligned on that tab. We can define that as a style, and then when we create new widgets, we can apply the style to it, or we can put on automatic guessing of styles, and then when we lay down new widgets, it will automatically align them. Notice that they jump to the alignment line, and they will automatically be converted into that style. We can also have styles that depend on the position, so the label style here, if it's in the center, is in a bigger font than when it's at the edge. Garnet and Gilt are available for free by Anonymous FTP, and we invite you to explore the system in more detail. Contact us for more information.